Programming Throwdown, episode 143, The Evolution of Search with Marcus Eagan. Take it away, Patrick. Welcome to another episode of the show, everybody. It's kind of crazy watching the ticker on the episode count go up and up. I always forget how many of these we've done. It's too many now. We're excited to be here with Marcus. Marcus is the staff product manager for Atlas Search at MongoDB. Welcome to the show, Marcus.
Thank you. Happy to be here.
Though we were doing a little bit of pre-show recording, I know we kind of hinted that sometimes. We already got pretty excited. Marcus was helping us understand search, something that personally I've already knows like Google, right? Search engine. But even though I've done database stuff before, my search always amounts to like equals checks and even getting those wrong because it turns out, anyways, it's difficult. So I'm excited to learn some stuff today. And I'm glad Marcus is here to help us through this. But before we dig into that, we always like to ask people kind of how you got into tech, your story, kind of like, origin story, Marvel superhero, whatever it wants to be. It can be kind of boring. It's all right. But like, Marcus, how'd you kind of like first get into tech? Was there like a moment you remember as like, this is the first time I got excited about computers or programming or?
Yeah. Like when I was about 11 years old, I was like taking apart for the fourth time my family's desktop computer. Just like opening it up. Like I got some tools, waited till my mom was gone from at work and my dad was cooking. And I started unscrewing like the panel. It was a compact computer. I remember like it was yesterday. And like when my mom got back from work, I knew I had the same corporal punishment coming to me that I had the first three times, which I didn't mind. Like it was worth it to look inside the computer each time and, pull something random out. But this time my dad intervened and he was like, maybe we should put him in this program. It was called DAPSEP. It was like Detroit area, like community education, something, or like pre-engineering was the program. It was like extracurricular. Every Saturday you'd go up to the university, was just a mile from my house, University of Detroit, and start learning about a range of topics in engineering, ranging from building circuits, like basic circuits, to programming computers on QBasic, using QBasic. So that was certainly my first time when I was like, okay, this isn't random. There's some logic to this. It's actually pretty cool. And one thing led to another. There was an extracurricular class. Well, my brother was studying computer engineering at first, and I would like look through his books with bewilderment and curiosity. Then my girlfriend, all we did was hold hands. We were 14. She like forced me to go to like web development with the calculus teacher in high school. So I went to his class and I was like, this stuff just clicked with me right away. In college, where I was really focused on mostly other areas, primarily, because I was much weaker in these areas, like research and writing. I found myself researching about computers and like the FCC and radio. So then I started to work on mesh networks with my friends, and like they're powering like internet for protesters and some of the big protests in New York City. We're, then trying to provide internet to migrant communities in Brooklyn when we left school, and then like impoverished communities just around the country. It turns out super expensive to build your own internet infrastructure and the ad hoc internet infrastructure. And it would be a challenge today. There's a lot of cultural inertia to go out and say, maintain, like invest in the hardware and then invest in the maintenance burden of maintaining a node in a mesh network. I think one day that will be important in certain regions in the United States, particularly like rural regions. But there's many areas in the world where these sort of networks exist. But like going from the web development to the networking stack really sort of gave me a well-rounded foundation and like the Q basic. And then how I really started to learn was when I struck out on my own and started my own company focused on like security for home networks, like IoT, like when you plug in your router and then set up all the devices you got for Christmas, some of those devices were made smart very hastily. And they would include, you know, self-signed certificates, for instance, default passwords, or use weak encryption. And like your network is only as strong as the weakest link. And I saw a trend in 2015, 2014, really, of people increasingly working from home and adding more of these devices to their networks. Like I would tell people like your drop cam, that's probably okay. But like the second, third tier IP camera, who knows?
Were you helping people like lock them down by, kind of just applying best practices? Or were you doing like pen testing against them, sort of figuring out, hey, this third party thing has some backdoor, or a little bit of both? Like, I'm just trying to kind of position like the kind of work you were doing.
Yeah, so we were just providing like an IDS, IPS system, mostly focused on IDS. So like you actually buy a hardware device, and then we have a device that's sort of like a sandbox in between your router and your modem.
IDS is intrusion detection system.
That's right.
Okay.
That's
Okay.
right. So, we drop a Linux box, an embedded Linux system in promiscuous mode in your home. And then you
You
just
tell
like,
people that if you go to someone's house and say, I'm going to put this promiscuous mode network card in your, like, I feel like they're going to think something and it's not the right thing.
no, well, like, that's right. It's better to know who's in promiscuous mode on your network than to not know, right? Because there may already be some devices, some promiscuous devices in there. And it was just like, it was a super hard problem. I still don't know how big of a problem it is today, even with 100% of people working from home in these knowledge positions, knowledge jobs, working from home in some capacity. Like I think the home remains an attack vector, but like that company was bought by another company kind of going after a mesh networking problem, which was funny. I was like, this is going to be really, really hard, folks. And they're like, no, just focus on the security and observability stuff. And I'm like, fine. But like, I think that remains a hard problem. But as a part of that, work for months, people were just, we're just mostly out of the box threat signature. Some stuff we tuned. It's very difficult to do this. We were collecting a ton of data, and we had done some interesting things with like determining what kind of device something was in a home network with high confidence. But like actually introspecting this large data set, this massive data set of data from all these different, these heterogeneous networks proved to be virtually impossible without a search engine.
Okay. Well, hang on. There's a bit of a side topic I want to say. This thing you're saying, like the home network remains and like all these IoT a threat. And like I myself find like unsure how many is people hooked up directly to their ISP's modem, like their IoT device, and that's what's getting hacked versus people with a sensible, they have a router with some basic default firewall rules and NAT. And like, I don't know on balance what it is. But I am shocked. I did very little bit of security stuff in college, just some basic like SQL injection, some like payload, Stack Overflow stuff, just enough to kind of like, oh, okay, I get it. But there are people I work with who went to, 4-year degrees at big name schools who are like, they don't get it. You say, they're like, oh yeah, hackers are a thing, but like my home network's not a big deal. Like that's not true. Like you wouldn't actually encounter in the wild like a Stack Overflow that doesn't just crash your computer. Like the belief that you can deliver a tailored payload automatically via like a worm or something, like they know it exists, but they don't think it'll happen to them. And so I'm like shocked how even people who should know better or even understand the mechanism, how these work, and by the way, have seen each other's code, like they still don't believe that that's like an ongoing threat. It's actually shocking to me.
Yeah, I mean, that's a great question. I think that we as software engineers suffer from groupthink tremendously. And confirmation bias is like, if it compiled, it must be good. Ship it. You know what I mean? And folks are moving fast. It's a super competitive space. There's a lot of capital flowing into software. So there's a lot of people like doing it, right? Chasing that. And we have seen recently, like the cryptocurrency industry is, well, it's great because it's like you can express money directly in code, whereas like typically it's an abstraction, right? It's like most ways programmers interface with money is a shallow copy. So like a shallow copy, for those who aren't familiar with this, like it's a reference to something. It doesn't actually represent the thing that you're pointing to, right? Specifically in memory, or like, but like in this case, shallow copy of money is like, okay, I'm using Shopify. I have a Shopify checkout button. That Shopify checkout button talks to Stripe. That Stripe API talks to First Data or some PayFac, and that PayFac talks to some mainframe stood up in like the 1960s. Who knows what that's running? Somewhere in Atlanta, probably. And with like the cryptocurrencies, what I found so fascinating from a security standpoint is you can point to, and I just started learning Solidity early this year, like for the second time. This time it was a lot easier.
Ethereum's programming language.
Yeah, Solidity powers the EVM, or allows you to, interface with the EVM. That's right, Ethereum virtual machine. And like what I found so interesting and profound about it, and I'm assuming this is how it is in all of them. My knowledge is limited there, admittedly, is that you can point directly to value. It's like a deep copy that you're like, that this money exists really in the world. It can be spent for like goods and services, and that's in your code. And so the security mishaps, the mistakes that are inevitable to happen in all software impact people a lot faster. In the case of that, there's like some folks working on like these bridges between two chains, and that's a super risky endeavor that I'm staying away from all the way. And like people lose 400 million and it's gone right away. And people feel that. They know it, which is important to me for security, because if you look at the Target hack, you might remember that big Target fiasco, 2014, maybe 2013, where the HVAC system, a contractor was debugging the HVAC system. Their home network was compromised. Their VPN credentials were compromised. Folks, a command and control server somewhere was able to then skim credit cards because they were on the same network as the HVAC system for whatever reason. I'm sure that person isn't employed by Target anymore. Not the HVAC person. They probably still are. The person who put those on the same network. Like once once those credit card numbers were taken and those credit cards were used, there was a charge back to Target. Like the credit card user is just like, hey, wait a minute, these aren't real. Or how did they get my information? Is it because of Target? Target was the last place I bought something, and then all this stuff showed up. So like you can see how it's a little convoluted to the consumer, the end user of these computers, like what was really at stake for me. Whereas like it's going to become more real for people today because of the connectedness and the cryptocurrency realm. And I'm talking about not using exchanges. That's different. That's more like what we're used to. But I'm saying like having a wallet and storing the primitives.
Yeah, I think the interesting two things I would say, like from listening to that about cryptocurrency, which we reference obliquely all the time because it's a hot topic. But I'll say that this thing you mentioned about bridge is the interesting part too, is you don't need to put a bounty on them because the bounty is already there. Like the money is already there. So like there are people financially incentivized, game theoretically, to attack those things and to find the vulnerabilities and make themselves enormously rich, right? So like it's this very like high stakes, deep copy game, as you kind of mentioned. Like if you transfer that thing, you own that thing, and short of them rolling it back, which is a whole other, thing we could talk about in decentralization. But you're right. I think that's really interesting. And the second thing is the amount of sort of game theory economics that I hear software engineers talk about. Okay, Jason, if you go back and listen to the show, 10 years has been talking about economics and his curiosity. But like now, I feel it brings those things a lot more to the forefront where people are engaging in a broader space of society than just, I write my program, it compiles, I do my web thing, and I go home. And I think outside of startups, people in big corporations, which I'm included, you can sometimes shelter yourself that you just write your code and it's this little, widget in the big thing. And I think in cryptocurrency, whatever, not it's good or bad net, but like this fact that software engineers think more broadly about societal impacts, I think is a good thing. I think like what will happen, but that broader thinking, I think is net good.
Yeah, they NeurIPS, which is a conference for neural networks and AI and all of this. They actually forced, or not forced, but they put in their spec that you all the submissions to NeurIPS have to have a section on societal impact, and so it's really kind of bringing it to the forefront. So I mean, it's something everyone has to be aware of now.
Yeah, I think that's so prescient, right? Like people still want to talk about like cybersecurity and computer security, network security as like this specialized thing. Today, in 2022, the vast majority of crimes are committed online. The like way more pervasive than, armed robbery ever was, right? It's just because you can automate it, you can scale it out on these hyperscaler cloud infrastructures.
Yeah, have you seen the meme about that? There's this meme where it says organized crime in the 1920s, and it's these Sicilian gangsters with the bowler hats and everything. And it's like organized crime in 2020 is just a call center.
Oh. Okay, well, you had perfectly teed up a segue for intrusion detection and prevention and trying to do pattern matching. And I heard it coming. You had the perfect teed up segue to search, and I kind of busted it because I wanted to kind of talk that. So I'll re-tee it up for you. You were talking about, sort of looking at signatures of payloads and packets and trying to understand and compare, and how this is a very difficult problem. And so maybe we can pick it back up there.
Yeah, it's like the home network was especially hard to try to build a business around because they're so different. Like every home network is different. Some people are Xbox families. Some people are PlayStation families.
No.
So some people are Oculus families. Some people are HoloLens, Xbox, Oculus, PlayStation, Nintendo Switch. They got everything. Plus, like a smart toaster, for crying out loud, and like a sous vide, like
Wi-Fi
on the Wi-Fi.
I never get it. Yes.
And so it was like differentiating noise from, a high fidelity threat indicator was extremely difficult. Doing it in a structured manner was practically impossible for it to be cost efficient. And so search it did two things. One thing was it enabled a broader swath of analysts, right? So like people who didn't necessarily know a query language, in terms of the JSON API or the syntax in MQL, like they just needed to use a search box or a few search fields. And then the other one was there were so many different fields. Like there's no unified schema. Like we can sort of enforce one in terms of what we're like sending from our Linux devices. Like we have like initially just Lua, like writing whatever was in standard out from the IDS to the central repository. And then later the system we were working on was just like throw everything in Elasticsearch. Some fields we knew about, some fields we didn't know about. And to filter on like a non-deterministic number of fields in a performant fashion, Apache Lucene, the subsystem there, was really powerful and remains really powerful for that kind of work, for log exploration and for finding a needle or a couple needles in a haystack of several million logs, several billion logs.
So this sort of like log data you're mentioning with indeterminate fields, I mean, I guess that gets at people kind of talk about this difference between structured data versus unstructured data. So this kind of fields and set length and set things would be if you were emitting your logs in a very, very, very standard fashion, then maybe searching for a time range or whatever would be pretty easy. But if you don't have control over some of that, but you're still collecting it up and looking, that's where you would start to use something like Lucene.
Yes, I would say so. But like even if you structured it, if there were a lot of different combinations and you wanted to give access to people who had like a long list of things they could look for, like maybe thousands and thousands of potential search queries, then Lucene would also be good for that.
So I always kind of thought Lucene, and I guess I'm wrong, but that's okay, I'll admit it. So I always thought Lucene was, I knew more sophisticated than this, but what I would say I kind of knew as fuzzy matching, which is like I put in a query term, and rather than this equals equals thing, like I was mentioning in the beginning, which is how we all kind of start, like it was doing something a little bit more and a little bit fancy. Okay, a lot fancier. But what you're saying is something more than that. Maybe it does that, but it also does this like more free form text that you can input and sort of going over across the different fields of your data.
Yeah, that's right. I think that fuzzy matching is an important point, though, because it goes back to like letting more people, like a broader user base of analysts in this case, maybe, or SOC employees, security operations center employees, like search. And that's because Lucene implements the Damerau-Levenshtein edit distance algorithm for determining in a performant manner if token is an edit distance of less than or equal to 2 away from what exists in your corpus or your search text, like your collection. If it's less than or equal than 2, it can quickly correct that query to find what you intended to type. That's how the fuzzy works. So like, say you have a list of companies based in the Bay Area, maybe a few thousand companies based in the Bay Area, and Google is one of them, but you're on your phone and maybe your fingers are fat like mine. So you type GPPGLE. If you change one of those P's to an O, that's an edit distance of 1. We've made one edit. You change the other one to O. Now you're at 2. You've maxed out, but you match Google now. And so that's something that Lucene does out of the box. It's pretty good at that. I haven't seen, any other system as widely used for that purpose.
I guess now we're sort of shaping up like the field of search. I guess we're kind of entering that. Like if we have like a database, and maybe people have seen like a SQL query where you're not going to be able to say like, I want rows which equals Google and it matched GPPLE, right? So we're already talking about like one layer of more sophistication where you're sort of like, let's just call it row scanning, like going through every row and looking for stuff. But I guess like some of these things you're saying could be done there, row scanning, but also you needing to do sort of some kind of pre-indexing and sort of it feels like this is where we move from like a programmer doing something else who tacked it on and is trying to find something to a sort of like, let's call it like a field of study, like something more sophisticated and building up the systems. Do I kind of have that space, right? Like, I'm not sure. How do people who do search like kind of talk about search?
Yeah, I think that the way people talk about search that do it often talk about the differing index types. So like B trees have been around for a while, and those exist in databases, and they allow you to pinpoint, a row based on a field and some matching criteria pretty efficiently, pretty fast. Inverted index kind of turns it on its head where like you're looking through a bag of words and you're trying to find all the documents in a collection, all the documents in an index that contain some word. And there's ranking, TF-IDF. I mean, most people use BM25 today, which TF-IDF is a part of that. TF-IDF is That's referring to term frequency over inverse document frequency. So you can think about if Marcus appears in one document in a 1,000 document corpus, but Marcus appears several times in that document is going to be surface higher than any, it's going to be the only document surface because Marcus appears there and many times. But if Jason appears there, but also appears in another document, maybe the Jason document, like about you, like, so you appear in this document as the co-host of a show that I appeared on, in the Marcus document, but you appear in the Jason document many times, and you search for Jason, the document where you appear many times will appear first, and then the Marcus document will appear second, because you appear more in that second document, and it's about document frequency. But like the word "the" would not be a strongly ranking keyword or search criterion for either of us, because the inverse document frequency, like, it's punished by the fact that it's in every document. And so most people will pull that one out in most use cases because it'll be categorized as a stop word.
Oh, so this is now, okay, I have no idea what year, but like early search engines, let's say, which you go to a website, you type in, you're looking for documents. I guess in this case, those would be web pages. And you end up with those people at the bottom who would put like the same word repeated like 1,000 times in the same color as the background of the web page or whatever. This is what they were trying to game, is they were trying to make a certain word appear far more often in their web page so that it would go up the search results. So, okay, I see. Now that's very interesting. And when you say stuff like stop words and the word like Marcus, and we were talking about this a bit before, but it kind of gets into a little bit understanding the structure of people's language, like people talking normally into this, typing normally into the search box, rather than sort of curating what they're searching to what they think is in the documents. So like as a programmer, if I was going to search something programmer, like I would type in a very specific enum name or something. But here we're saying if people are using the word "the," they're kind of talking normally. They're just sort of writing what they would say into the search engine.
Yeah. And I think that gets at what I think is the heart of search, what drives so many people to search and makes it so compelling to me. What many people hope for, some people explicitly don't want this, but what many people hope for is that computers can embody many human characteristics so they can help us with things. Like, I don't want to paint my room. I want my computer to do it. One of them, I don't want to do my homework. I want my computer to do it. I don't want to cook dinner. I want my computer to do it. I don't want to drive. I want my computer to do it. And so, like, it's no coincidence that, like, the leader in autonomous driving is Waymo, which is a subsidiary spinoff of the largest search company in the world, right? Or computer vision, which also came out of search. It's because with search, you can interface with the computer in a way that you interface with humans day to day. What makes humans so special is the ability for us to communicate. That's what I hear anyway. So, like, maybe we could improve our communication, but like in a world where you can talk to your computers and get like meaningful responses, it is really powerful and at the heart of search. Alexa, Siri, they're both powered, to some extent by Lucene.
Today's sponsor is Mergify. Mergify is a tool for GitHub that prioritizes, queues, automatically merges, comments, rebases, updates, labels, backports, closes, and assigns your pull requests. Mergify features allow you to automate what you would normally do manually. You can secure your code using a merge queue, automatically merge it, and many more features. By saving time, you and your team can focus on projects that matter. Mergify can coordinate with any CI and is fully integrated into GitHub. They have a startup program that could give your company a 12-month credit to leverage Mergify. That's up to $21,000 of value. Start saving time. Visit Mergify.com to sign up for a demo and get started. Or just follow the link in the show notes. Back to the episode. Okay, so does Lucene help there? So when you say this, I'm going to mess up the letters T, F, I, D, F, and you're sort of saying like, I'm taking the words written, maybe you allow for edit distance. But now when you start to say like, we talk as humans and communicate, I start to think like meaning or semantics or like I'm saying a term and the thing that I want may not actually even contain the words I typed in.
Yeah, I think this is such a good question because I think about it all the time. We talk about it internally all the time uh, here at my company and on our team. And that is like inferring human intent and inferring customer intent, user intent. It's a bit of a dark art, right? You have to know something about that person to know where they're coming from, like their perspective, right? So what makes surfacing this data for a user that's relevant to them before they even know what they're looking for, that's kind of what you're talking about. Is like find something based on criteria that doesn't even exist in the corpus. Is it's all context driven, right? So if you ever go to like Safari for the first time, or if you're paranoid and only use incognito, like they'll ask you, do you want to allow Google to know your location? And it's interesting. Most people are going to, say allow. Some people are going to say don't allow. But if you say allow, the likelihood is that the relevance of the results that Google shows you will increase. Because if you search, let's say, Chinese food, and Google knows you're on 52nd and Broadway, it's going to show you Chinese food in Manhattan near 52nd and Broadway. It's not going to show you like the really dank spots in Flushing. There are some really good spots if you want to hike, but like it's going to show you like those spots are going to be considered because they're rated so high, but the weight of proximity, geo proximity, will pull these other restaurants nearby. And even some restaurants that aren't necessarily Chinese restaurants and just have dishes with similar ingredients are also going to surface.
So to like riff on this, because I think I thought about this before too, is like if you typed in Paris bakery and the search engine knows nothing about you, should it show you like bakeries in Paris? Probably like without knowing anything about you, it should go to Paris and find whatever using all these things you said, like give you bakery results. But if you're like, I don't know, around where I was in the Bay Area, there was like a restaurant called Paris Bakery. And so if it knows I'm in the Bay Area, rather than showing me something which could have been what I was looking for, but like Paris Bakery should probably match to the restaurant named Paris Bakery. But if I'm in Iowa and there's no Paris Bakery, it probably should still show me the ones in France, not the one in California that's a relatively like unknown, kind of minor restaurant, not a famous restaurant or anything. And so I think that dynamic you point out is like really interesting. Like it's more than just knowing at a human level that like these words mean this thing, but that meaning isn't universal. A human at a certain time in a certain place saying those words means something different than another human in another time in another place.
Yeah, that's right. And like, I think a lot of people think about search in the context of Google, which is like a generalized search engine, kind of, sort of like Bing. I haven't used Bing in several years, but like, I think Bing's still out
okay,
there.
You can admit it.
Yeah. Like the problem changes if it's a domain specific search. So if you're building a search for your application, right? Because Paris in a restaurant search app or a recipe search app or, something like along this line, or even a movie search app, Paris might be a synonym for France or Parisian, or French. And so then Paris bakery also means France bakery and French bakery. And for sure, there's many French bakeries everywhere because the pastries are...
Or anywhere that serves croissants. Yeah.
Yeah, right. But there still are, French bakeries, even Parisian bakeries in places in the United States, and obviously all over France and Paris.
I was just going to say, so maybe if we think about like, I'm an engineer, I'm building my program, I start to collect a whole bunch of data. And I want, like you said, either users or analysts need to be able to interact with all the data I'm gathering. I guess I should have picked a specific example, but I didn't. And sort of, I know something about my domain. I know I want to allow this sort of semantic kind of searching to take place and fuzzy matching and really empower people to interact and surface results that they want from my specific thing. How do I go? Like, what is the trajectory I would normally go along? So first, you might do like a text search and SQL query. We talked about Lucy. Like, what is the kind of arc of how that happens as an engineer starts to build up a set of things they want to search?
Yeah. So the first thing is like indexing and running your first query. Just like default index, run your first query, have an experience feeling it. Like, I'm a big proponent of, like, as a product manager, really focusing on how it feels to use a product, right? Because I've been in the place, and I spend 20% of my time doing this today, continuing to do this, like banging my head into a wall, like trying to really get at it. And when I do that, I get a sense of where there's opportunity to improve. So when you are setting out to build that, you need to do it. You need to bang your head really quickly, index some data, query that index, understand the output, the format of the output, the information, the metadata that you have exposed or available to you. Then secondly, you need to refine that index to make it more suitable or useful for your use case, right? So that might include pointers to a few synonyms collections. That might include language-specific analyzers like English or French to strip away the stop words and handle the diacritics appropriately. Diacritics are like those squiggly lines under the C in Frances.
Today I learned.
Or like the accent over the A in hola. I think that's right. And in Spanish. And so the next thing, once you you understand like what your language analyzers are, you have your synonyms collection and your maybe some facet fields for the low cardinality fields. Low cardinality, again, if I'm using complex, cardinality is just like how many unique values are in an index in a corpus. So for example, imagine a movie search engine, there's only like 5 or 6 genres, like comedy, horror, drama, fantasy, thriller. So it's, something like that. So romance, or bromance, not like you want to make that a facet field because those are fields that the customers can filter on. Even though there are 100,000 movies, that's a good candidate because it's low cardinality relative to the number of documents to help you whittle down to what help your customers find what they're looking for. But so once you've tried it, you've made an index, the third step, if you're building in a really sophisticated system now, like I'm kind of like the third step could be go build your UI, but like if you're building a sophisticated system, the third step would be to start to try to understand the queries. So what's interesting about the Paris bakery example is for a sophisticated system, it might tag Paris as a location and bakery as a geolocation. They might like draw a polygon even on the map. Like Lucene has these capabilities. Like it has via the lat long query parser, it can draw a polygon really
For Paris.
For
Okay.
Paris. And you can read about tessellation and Lucene another day. It's a topic of a PhD probably. Actually, I think a few people have done their PhDs on this field. But like Nick Kneise, I think, is one. But like, yeah, you can draw a box that is Paris, that's a polygon, and then bakery is a point of interest. So you got this geolocation and you got this point of interest. Bakery is a place. That's stuff. Like that's a thing. Paris is the constraint on it. And so how you understand that query shapes like what results are returned. So you have a geo constraint, that will be a filter. you're only showing bakeries in Paris. And then bakery would be like a must-have condition. So like bakery must appear in these documents in my corpus, and Paris is the only place where I'm looking. This is in one use case. Like it depends on what your application is. And so Paris, what you'll see is there's some limitations there. You will get some documents you don't care about. Like there's going to be grocery stores that have the word bakery in them, but you really want it to go to like a specialty bakery. There's probably going to be coffee shops, cafes in that list because maybe baked goods or fresh from X bakery will surface. And so then like there's the next step once you have this query understanding, right? Which is about taking the historical user data, like how people have interacted with their search results over time should influence like their future results. But like, just so we're clear, understanding that query and constraining it to that geo field and then that point of interest, that requires like a flexible schema, a flexible data model, right? So like right then and there, we know that a database, relational database, like in a traditional sense, is just like not a good candidate for that. I mean, listen, I know what these some professors are saying at universities about this technology from the 60s, early 70s about relational databases. They just don't fit the use case of modern computers today and like how humans interface most of the time, right? Because, and like Amazon, Google, they're not relying on relational databases much for these things, right? They're using like this flexible data model that can evolve to meet your needs. Now we know our customers are querying by geo constraints. So we need a geo filter field even. Then now we know about this point of interest. So let's have a point of interest field. Once you have those, you take the user's interaction with the results to understand the quality and even segmenting those users, right? So some people like to store like a hash of every user. I mean, we know many companies that do that. I won't name their names. I think probably even more valid to have buckets like personas, segments, where these are living categorizations where some people may be in one segment for part of their customer lifespan, and then they graduate or get demoted to a different segment or get moved around. Maybe all segments are considered equal and they just get moved around over time as their interest and interaction history changes. But that feedback loop is so important to cultivating like improved relevance. So you have the categorization, like query understanding. There's like lots of NLP libraries that can help you with that, and different techniques to help you, classification algorithms. Then the next one, you got the click history or the interaction history, maybe sounds a little less scary, or, the interaction history, the engagement, like what is driving success of your user and their journey, like, and then boost those results, those keywords. Then the next one, which is sort of a buzzword frontier that I really caution people not to jump into too heavily. Definitely not head first because it'll cost you. I think it's really important to try to understand those first few steps and then move to this step, right? So you could call most of that, you could categorize as lexical search, more or less, like matching, text matching, fuzzy matching based on lexical criteria, how things appear. Like once they get through the analysis chain, that's once they've been mutated by Lucene analyzers for easier retrieval. So friendship, friendly, friends, all match friend, FRIEN, because that's the root, that's the stem of it. So once you get through the like analysis, the indexing, which includes analysis, to the query understanding, to like understanding your users and how they interact, maybe even some automated synonyms based on zero results, because nobody likes zero results. You go into a store, you ask them, hey, where are these pants? And the customer service representative just walks away and doesn't come back and never answers your question. Like, you're just gonna let me walk out of here pantsless? Like, that's terrible. That's terrible. Like, if someone asks you a question, they are counting on you for an answer. So like the zero results is like an area where I have seen people have a tremendous impact, just like automating synonym generation or just going in manually and adding synonyms for zero results. That's why I think the synonyms capability is so important. But once you get through all of this, let me wave my hands and get everybody excited, right? It's like this era of semantic search, right? Where I've been exploring one of the more challenging data sets to search for like explanations of concepts in search that are really advanced. So there's one of the people you can blame for like Internet Explorer is the former product manager of Netscape. It's like Ben Horowitz. He's like also famous for making a ton of great investments in companies early and startups early. But back in the day, he was a product manager in Netscape. And they popularized the web browser. And he does this thing in many of his books where he starts with like a rap quote, which I love. And so I'm trying to do that as well, starting like the most recent I've done is like 10 years ago, maybe. I mostly go further back than that. And one of the techniques, this literary technique in poetry for, as long as poetry's been studied, really highlighted for me how semantic search works. It just sort of reminded me. So
this is a big tee up. I'm ready.
Yeah. Drake, before he was famous, he had this like mixtape and he's freestyling. Now he's the most famous, probably. I don't get to listen to him that much anymore, listening to new things. A lot of old stuff these days, electronic music and classical music, but that's neither here nor there. Back in the day, he said, we're getting Seinfeld on some Jerry and Elaine queries. Let's just say he said queries. I replaced another word there.
Oh, thank you.
and so we're getting Seinfeld documents on some Jerry and Elaine queries. And so what he was describing is really how our brains do associations, like how we find memories stored in our internal databases based on like cues or hints. And that's really how semantic search works. It's really built on neural networks to train these language models that can then tell you that when Jerry and Elaine, two first names, appear together, you may actually be looking for Seinfeld because Jerry and Elaine are two characters in Seinfeld. So they occur together a lot. Like, so you train this language model on thousands and thousands, billions of documents, really, billions of documents where humans have written text. Maybe it's scripts, maybe it's reviews, critiques, maybe it's like search applications for streaming. You have all these corpora, this rich body of text that contain both Seinfeld and Jerry and Elaine. They might even say Jerry and Elaine Seinfeld. I don't know if that's their last names on the show. I don't watch the show. But even when I hear Jerry and Elaine, for some reason, think Seinfeld. And so that's really what semantic search is about. Our team is working on releasing semantic search capabilities. They'll be available to users that reach out to me. The reason why we're doing it like that is because I want feedback. I really want to guide people to success. I don't want them to just assume ML is going to be a panacea for their relevance or result ordering problems, because that's not how it is. It's really important for an engineer to remind themselves every day that ML doesn't always win.
No, come on.
Because like my grandmother was she was about ready to throw her shoe at the autonomous driver of a car we were in, in the Bay Area years ago. We rode in the car, and it's like trying to make an unprotected left. And it's like, grandma, like, this is the first time it's had an incident. Aside from like dodging like one leaf sticking in the road, thinking it's an obstruction, like this is the only thing that was really a problem. And like, I struggled to make unprotected left. So let's, cut it some slack. But
Well, you should see what she does to you too.
yeah, exactly. ML doesn't always win, but it can help. It does have the ability to, even if you don't have to make a synonym for Jerry and Elaine should match Seinfeld. You can just have this Jerry and Elaine query surface Seinfeld. Just like in our early testing of our feature using open source models. Like the thing about today, the reason why we're releasing this feature now as opposed to 2 years ago is I personally felt that the quality, the robustness of the publicly available language models and search engines had reached a point where we could reliably let customers play with and experience the power of what's called semantic search and not have to have like PhDs in data science or statistics or information science to really benefit from these techniques. Like there's a ton of models out there from a variety of companies, and we strongly believe that the open source search engine that powers most people's search applications that are using search engines, because a lot of people are still using databases for crying out loud. Most people that use like search engines to power their search applications, we felt like Lucene had come a long way, and we also want to contribute to it more at our company. So.
Well, that was a great setup. So we moved through like the arc of search, and then you kind of started alluding to we and our company. So tell us a little bit about like where you're at, what your guys' product is, and sort of like, give us kind of the elevator pitch about what you're trying to do.
So I'm at MongoDB, and what I'm trying to do is exploit the flexibility and the cognitive continuity of the MongoDB document model to enable the widest swath of people possible to build advanced search systems based on the steps I just described. I wrote this on my blog recently, like the cognitive steeplechase of working with a relational database and the throes of tables and rows. It's like, so you telling me I call an API, that API gives me JSON objects. Then in my programming language, largely object-oriented paradigm, I'm building business logic around these objects and manipulating these objects. And then when I go to store it, I have to like effectively use a bunch of spreadsheets or file cabinets. Like that's how tables and rows feel to me. Like, my company, like I made all the use in the world of Postgres and stuff. It was like the cognitive dissonance, like when you're a smaller company and you need to be as efficient as possible and move as fast as possible, or even like a personal project or like starting a new thing, like the cognitive continuity pays serious dividends because I get frustrated less. It's like, imagine you're writing some code. You got your noise canceling headphones on, signaling to the world, leave me alone.
Not a very good signal, but yes, I know your intent.
Yeah, like, please don't bother me. And so you are in the middle of a function that you're describing, or like, articulating, expressing. You're like 70% of the way through. If somebody taps you on the shoulder, pulls you out of the conversation you're having with your IDE or text editor for 2 minutes, you might have lost the next 15, 30 minutes. You're going to come back and be like, where was I? What line was I on? Where is my cursor? Is Vim in insert mode or not? I don't know what to do. Like, I cannot touch the keyboard. Back away from the keyboard. Woosah, woosah. I mean, this is a real thing. This is a real thing. And so imagine nobody bothers you. You just went from the API to the business logic and this object oriented, paradigm to the tables and rows. It's the same thing. It's like tables and rows. I was just thinking about these objects. Boom, boom. What? I'm surprised. And so as a part of your workflow, every 15 minutes, you lose another 15 minutes. It's crazy to me that the discontinuity between the storage layer and the logic layer, or like the external system, the access layer, the data layer, if you will, like the discontinuity between the storage layer and most systems. So that's why I was like, okay, MongoDB, I need to return there. I built a startup on that continuity. I know how much faster I was able to adapt and innovate and change and mutate and really push out features because I was kind of on the same wavelength. Like nobody was interrupting me. I wasn't interrupting myself. And so I was like, if I really want to get this out, if my dream is really to like get the power of high dimensional vector space to the world for a variety of applications. It's not just a search box. Remember, search engines are the technology underlying so many different technologies, whether it's like fraud prevention, personalization, recommendations, or like drug discovery, gene profiling and descriptions, like predicting interactions. Like this could be life-changing stuff. And so like the way I'm going to get this to the world is the path of least resistance, which I certainly see as the document model that's been pioneered by MongoDB. At this point, they're not the only ones because people have like wisened up. They understand now, but they built the most robust business around this value prop and certainly the most robust managed service, which I think is just like, it has to be managed because that's another thing. It's like, okay, if I get the document stuff figured out, if I have to go think about racking and stacking servers, like I feel like I'm in 2008 and like AWS isn't a thing. It's like, come on. Like there are these managed services, you should use them. Like engineering is, for me, a quest to simplify. Constantly iterate to further simplify. And MongoDB really let me do that. I was in grad school at the University of Michigan, in the School of Information. And like, I learned a lot of things really quickly and I didn't stay for very long because it was super complex. It wasn't like, I understood what was going on, but it was like, I need to go to the world and tell them you don't need to do this. Like, I want some people to go to grad school. It's like, but you can, like, with MongoDB, if you're in high school, you can get started. Like, there is a free tier in Atlas. It's free forever. If you're mid-career, you're 40, you want to keep your skills sharp, you can go get started. You can load a sample data set for free in a managed service nearby your house. There's like 90-something regions supported all over the world. You can get started and you can create a search index with a click of a button or one API call. And then that's really powerful to me. At the end, I'll say, all set, you're done, or you're all set. And then you get a little button. You can just click it, type into the search box, view the query syntax, and you're off to the races. And so if we get all of that out the way and make that part simple for you, then you can understand or like even start down the path of, hey, I want to run every query that comes in, every text query that my users provide. I want to transform that into a dense vector and submit that to MongoDB as a vector input and then calculate some similarity, whether it be Euclidean distance or dot product or cosine similarity of that query vector to my corpus of vectors to surface documents I didn't even know were in this corpus or relationships I wasn't even aware of. That's super powerful to me. And then you talk about audio, video, like next we're going to be ideas if we ever get this Neuralink thing.
So you're doing my job for me. I was just going to ask. All right, but it sounds like, okay, so Atlas is the managed instance, managed service for MongoDB. Is that right?
Yeah, that's right.
Okay, cool. So if people are listening and they want to try, it sounds like you already did it. I'm just repeating it, but they can go sign up on the website. They can put some example data in there. They can start searching. They can really kind of experience that. I think that's an awesome opportunity. I think people listening who this is not your field today, or even if it is and you're interested, doing that firsthand experience is one of the best ways to learn, one of the best ways to immerse yourself. And I think, as Marcus was describing, hit your head on the really obvious problems first before setting out to solve the hardest problem, and really kind of advance the understanding and learn what you need to layer on next. I think that was wise words.
Just great points. Thank you.
But the next question is what about working at MongoDB? How is working at MongoDB? Are you guys hiring? Do you do internships? Where could people look? What's the kind of culture like? Just kind of give us the spiel about a life there.
So we're permanently hiring, if that gives you any insight into how much work there is to do. We're powering mission critical infrastructure for a lot of the world. The whole world runs on MongoDB, seriously. And so many applications you would never even think of. There used to be this joke, oh, MongoDB is web scale. No, it's not. So whatever. Yes, it is. Or whatever you define it as. There's a lot of people using MongoDB at super high volumes. And so what that means as we move to support more of the demanding customers in the world, many of them, I think something like 4 out of 5 financial transactions, something crazy like that. But all these really large use cases means we need a lot of help. And then we're also very focused on the developer. And so we don't go as fast as some of these companies. You'll hear people talk about, as I get into the culture here, you'll hear people talk about, we ship to production, 12 times a week on average. That's not how we operate, because we're focused on your experience. How does it feel to work with this database? If we ever start to break that cognitive continuity that I think is our biggest advantage and worth so much more than people have realized, then I think it becomes less of an interesting place for me. Because right now it is the simplest way, to make use of your data, to get to a place where you can innovate fast and really start to explore and push the boundaries and iterate in a lot of features. So you can rest assured we're not moving super fast in that way. But relative to the other database companies or infrastructure companies, we move pretty fast. And maybe it's because we have that continuity, right? Ourselves. We work with the database all the time, so we can move faster. We have just tremendous set of internal tools and applications powered by MongoDB. And that's one of our competitive advantages. It's we have our people working on these systems have the cognitive continuity. Some teams lean sort of academic in nature. Some teams are newer and maybe play a little more fast and loose, doing a lot of experiments, really trying to figure out what's the right direction, what's the right thing. There's a mixture of roles ranging from we have an education engineering team, which builds MongoDB University, which is a free portal where you can go and learn MongoDB if you're not being taught it in school yet, right? Which I think everyone should do it because it's free. Or if you're not being taught it on the job, definitely go to MongoDB University. It's awesome. Helped me tremendously. And then we have a Docs platform. We maintain our own Docs platform. And then we have the managed service in the database and the search system and the mobile database and the serverless functions and charts and some of these things go very, very, very in the weeds, but you can rest assured coming to a place like MongoDB, you're surrounded by world-class minds, world-class talent. The predominant storage engine and Oracle today was architected by Michael Call and Keith Bostic, and who they wrote it. It's called Sleepy Cat, and this is like in the early '90s or something. Oracle bought Sleepy Cat. Then they built in the 2000 teens, I believe. Michael Call and Keith Bostic came back together, started a new company, and they built Wired Tiger, a new storage engine. And MongoDB acquired the Wired Tiger company. Keith Bostic, who recently retired, told me that Oracle didn't want the design. And so, like, which storage engine do you like? Would you prefer Sleepy Cat or Wired Tiger? It sounds like this great full circle.
Oracle in there, so you're really covering all the bases.
Yeah. I mean, like, we're gonna be like MongoDB is the next generation of data storage and access, information retrieval, and so, like, I think that you come to MongoDB to be with the experts on the cutting edge, work with the fastest growing companies and the fastest growing database company alive. Everyone is really nice. They work really hard to make space for all kinds of people. Like, there are several people, including myself, who might be characterized as a little weird, but it's fine.
No, never.
Yeah. Like, I spend all my day thinking, like, I mean, my brain is an inverted index at this point. And so, like, sometimes I surface documents that you didn't intend to surface. And, like, other times it's exactly what you're looking for. It kind of had to be tuned. And then, we have engineers in New York City, our headquarters. Dublin is our EU headquarters. Dublin and Barcelona and Berlin are both growing engineering offices with openings, and we have field engineers. Like, you can come here if you want to write just a little bit of code, right, or a certain subset of code, and work as a support engineer or consulting engineer or solutions architect. If you don't feel you want to, like, be only coding, right, which the software engineering organization. We also have a large team in India, I believe in Singapore. We have a pretty big engineering team in Australia and also San Francisco and Austin. And we have, like, field teams all over the world. We follow the sun there. And so it's a pretty exciting place to be. It's very diverse. I think we're getting better in pretty much every category of diversity. And we don't just think about, like, what someone looks like. It's also, like, what's their perspective?
Well, that was great, Marcus. And, I think this has been super helpful to me. I mean, I learned a lot through the podcast today. This idea you said, it wasn't even like the topic of search, but this, like, cognitive continuity. People who work with me hear me talk about, like, cognitive burden. It's like kind of, I feel like, very similar concepts, like really helping people make sure that when they're engaged and in the flow, that this is something worth optimizing for, that making sure that whatever you're doing, users, people writing code, like making sure that you sort of reduce the amount of simultaneous complex concepts that have to be held in your head. And I'm with you there. And I think this has been, like, really awesome. I know the listeners are going to really enjoy hearing this tour de force, really, of search. You covered, I don't know, probably 1,000 Googleable terms and, years of study probably to get to the bottom of all of it. So I really appreciate you coming on, and I really thank you for taking time.
Thanks, Patrick. I really appreciate it. Thanks, Jason. Really appreciate it.
Yeah, thanks so much. This is absolutely amazing. I mean, there's a ton of terms here. I think we covered a whirlwind of things. So, folks, if you have questions, just we'll post Twitter handles. You can @ us. You can @ Marcus and ask questions and get engaged. It's a really interesting topic. Super, super important.
Yeah, if you want early access, I would have to plug it again to semantic search capabilities. We're collecting, people to get early access to those capabilities because, like I said, we really want you to ensure that you're set up for success and you're not confused and that you can use it in a way that's cost effective and allows you to really benefit from the technology.
Well, thank you, everyone. We'll see you next time.
Music by Eric Barndaller. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.